Okay, let's take a look now at the next definition, is the norm of a vector. The norm of a vector is a measure of its magnitude. Yeah? Is the actual length of this vector. Sometimes it's also related to distance, as we will see in the k nearest neighbors algorithm. And there's different norms or distances that you can look at. For example, in this case, assume that, and we put this between two vertical lines. If we want to calculate the norm of this vector, then we use Pythagoras. So this piece is here Vx, and this piece is Vy. So the L2 norm, and we write it like this, with the 2 here, equals the square root of Vx squared plus Vy squared. And that's nothing more than Pythagoras theorem. Okay, this is Euclidean distance. It's what we typically use in our daily lives. We will also mainly use this one in machine learning. There's many norms. There's an L1 norm as well. An L1 norm, let us define an L1 norm. So you have two vertical lines and a 1 here, equals as simple as Vx plus Vy. This is Vx again, and this is Vy. Okay? When we talk about distance related to the L1 norm, it's called the Manhattan distance. Yeah? Give you a quick intuition here. Sometimes we have data, like this here, all data points, and you want to know, for example, if it's a classifier, so you have your decision boundary here, and you want to know what class this red dot belongs to. The k nearest neighbor algorithm says that take a look at the point that is nearest to the dot, and so give it the same label. Yeah? Nearest means distance, right? That's why we will use distance in this case. Okay? Dot product, very important. The dot product of two vectors is a scalar. That's very important to understand, and it's also a measure of similarity. Intuitively, what is a dot product? You have here a vector v1, v2. The dot product is the projection of the vector v2 to v1. So I project, yeah? And so the dot product is v1, v2, cosine of theta. Yeah? So it's obvious that if theta is 0, the cosine is 1, your dot product will be maximum. Yeah? So high similarity. V1 is perpendicular to V2, then the cosine of theta, in this case 90 degrees, is 0. Yeah? So they're totally not similar. Yeah? So we're going to use it as a measure of similarity. Now, how do we complete or calculate this? I define two vectors, v1, v2. The vector has n rows, so it's an n row time one column vector. Here the same thing, n rows, one column. v11, v12 to v1n, v21, v22 to v2n. Yeah? If we now do vector 1 dot vector 2, how do we calculate it? Well, we do v11, v11, v21 plus v12, v22 plus all the way to v1n, v2n. Okay, so we can write this as the sum from k is 1 to n of V1k, V2k. Yeah? Just a small detail here. I cannot multiply or take the dot product of these two vectors because as we will see, if we want to multiply, this number and this number need to be the same. So basically what we're going to do is we're going to transpose one of the vectors. Once we transpose, this becomes a 1 times n, and then you see the n and this n are the same, and we can actually do the operation. Yeah. Other notations of the L2 norm are V transpose dot V, square root of that, or the same as V dot V transpose, also the same square root. Yeah. So this is the next set of definitions. We can also have a zero vector. Zero vector. That's basically the point 0, 0 in a two-dimensional space. And we can also put a line on top of the 0. And then we have the unit vector. Remember in our drawing we had the unit vector 1x, 1y. So the unit vector equals the vector v divided by its norm. That's the unit vector. Okay, this was it for vectors. Next item in the line is a matrix.